Go ahead and get started here. Hello, everyone. Happy New Year, and welcome to Inspectioneering's first webinar of 2025, Bridging the Experience Gap, How Mechanical Engineers Can Overcome Industry Challenges, brought to you by our friends at Becht. My name is Jeremiah Wooten, and today I'm excited to have Nathan Barkley here with me to discuss a serious problem for many organizations right now, particularly in the refining, chemical, and petrochemical sectors. And that is this widening gap of expertise and institutional knowledge being caused by a multitude of factors, including a large number of retiring engineers and inspectors, industry consolidation, inadequate training programs, and the ongoing struggles with recruitment and retention. But before we get into all of that, let me first introduce our guest. Nathan Barkley currently serves as the pressure vessel group lead at Becht and has nearly 15 years of experience in mechanical design and analysis of pressure vessels and heat exchangers in the refining and chemical industries. Before joining Becht, Mr. Barkley was the lead design engineer at a top fabrication company building ASME Section 8 Div 1 and 2 equipment. So he's well versed in ASME and API codes for new and post-construction, including design, certification, fitness for service, re-rating, alteration, repairs, and inspection. So welcome, Nathan. Thank you for leading today's presentation, and thank you to Becht for partnering with us to bring this webinar to the inspectioneering community. Also, before we jump in, as always, I have a few quick housekeeping notes. First, all attendees' microphones and videos have been disabled. So if you have any questions during the presentation, please feel free to submit them at any point using the chat feature in your Zoom window. And this webinar is scheduled for 1 hour, and we will address as many questions as possible in the allotted time frame. If, however, we run out of time, all remaining questions will be answered at a later date. Also, for those interested in continuing education credits, such as API's CPD program, this webinar does qualify, and a certificate of attendance will be emailed within 48 hours to all attendees who watch today's session in its entirety. That being said, this webinar is being recorded, so if something comes up and you have to jump off early for whatever reason, a replay will be made available within 1 week on inspectioneering.com. So now that all of that is out of the way, we can go ahead and get started. Welcome, Nathan.
Thank you, Jeremiah. I appreciate being invited to do this webinar today, and I'm very interested in this topic, and I know it's been a point of discussion in the industry lately. I've had a lot of discussions with people, so I'm looking forward to presenting this today and seeing what kind of questions that we get out of it.
Absolutely.
All right, so as Jeremiah mentioned earlier, this webinar is titled Bridging the Experience Gap, How Mechanical Engineers Can Overcome Industry's Challenges. And today we're going to be looking at strategies and a number of other considerations for addressing that knowledge void within the industry. So with that, let's dive in. So the refining, chemical, and petrochemical industries are navigating an unprecedented shift as retiring and displaced professionals leave the widening gap in expertise. So that's kind of the fundamental premise that we are operating off of today, and that's what we're trying to address. It's important to note, though, before we dive in too far, that no two companies are alike. Some companies may be ahead of schedule, some companies may be behind schedule or ahead or behind of the curve. I'm aware of some companies that are being very proactive in hiring and being intentional with their learning opportunities. And so this webinar is not intended to focus on any one company or even one industry segment, such as solely refining. And it is addressed towards mechanical engineers, and that we play a key role in our industry. But we have had a series of continuing unresolved equipment failures. There are continuous safety risks. There's inefficiencies that are uh, being experienced in our industry, and we're going to look at some of those today. And it's also important to note that these considerations that we're going to cover extend beyond just mechanical engineers, just as a small subset, but it also can extend to inspectors within your facility, it could extend to operators, other plant personnel, or even other engineering disciplines such as process engineering or civil engineering. The general strategies are going to discuss can be broadly applied across the industry. And so um, all professionals on any level are dealing with an evolving landscape due to technology changes and corporate strategies changing. Seemingly, it seems like it's changing yearly. And so, just to summarize what we're going to cover here for this session, we're going to look at identifying some of those industry challenges and those industry impacts, uh, and just give an idea of what those are. We're going to look at some real world examples of consequences and some both very narrowly defined solutions as well as high level solutions that may help. And then finally, we're going to discuss the actionable strategies to rebuild workforce resilience and that expertise within the industry. And so, um, as I mentioned, this is intended to be broadly focused on issues that I have noticed. Um, and when I say industry, I'm painting with a very broad brush to include all of heavy industry segments, not just one refining. It could be upstream, downstream, any number of those. I'll also highlight that most of the issues we're going to look at today will be focused here in the United States, um, but there may still be some overlap with international experience issues. But just throw out the caveat that it is very U.S. focused. But hopefully there will be at least a nugget or two for everyone on the call today. So for our agenda, first up is understanding the gap, an industry-wide challenge, and that we will be examining some of the issues that the industry is currently facing, at least at a general level. Then we will cover key engineering tasks affected, which are 4 case studies that highlight real life deficiencies that are occurring as a result of our lack of experience or expertise throughout industry as a whole. Next, we'll be discussing closing strategies for closing the gap, in which we will discuss the various strategies that you or your company can implement to alleviate the gaps that we will have discussed. And then finally, we'll wrap up with a question and answer session. And I'm hoping that we have a lot of questions today. So feel free to submit any questions that you may have, and I will do my best to answer them. So looking at what we are facing as an industry-wide challenge, these are all generic examples and are applicable to different degrees across the industry and across particular companies. But these issues are affecting everyone from huge multinational companies to even your small regional facilities or little small mom and pop shops. I've had personal conversations with chief engineers at these huge multinational companies, and they are all struggling with these issues in some form or another. Again, this is broadly applied across the range, across the industry spectrum, but these are all real challenges with real examples. So first up, looking at declining expertise in the industry. And so we have an issue with retirement trends and workforce reductions in our industry, which we have a record number of baby boomers that are retiring, and they're leaving gaps in expertise that is difficult to replace. Um, Despite our best efforts, losing 40 years of experience every time someone retires with that level of experience, it's the equivalent of a library suddenly vanishing. And so it's definitely a issue to factor in. But on the other hand, there are also various factors that are contributing to less people being available for the same work with workforce reductions. And we'll look at some of those here momentarily. To also have less long-term investment into workforce development. Um, it's just a general industry trend that we have more focus on keeping the plant running or keeping your facility running versus um, having a great in-depth level of technical knowledge available to you. A lot of companies, a lot of the speaking for refiners directly, I know a lot of the central engineering groups are being cut back or culled, or the number of services that they offer are being reduced, and it is creating challenges even in the large refining companies. But then there's also some issues with consolidation of roles, and that leads to more generalist experience. And so engineers are expected to be a little more jack of all trades, if I can use that expression, where um, it's much more difficult to have a very, very in-depth technical knowledge, um, just given the sheer number of the broad range of spectrum of experiences that you're expected to have. So that is an issue. Shifting to the next major topic, there are certain industry dynamics that are also coming into play. We have consolidation of oil major companies and even smaller refineries, and they're all relying on the same number of SMEs. And over the last decade or so, there's been a flurry of acquisitions and consolidations across the industry, and there's less people responsible for the same amount of work due to that consolidation. And there, as I mentioned, there's facilities that used to have access to corporate engineering support, that used to have access to high level SMEs to answer questions on refractory or piping or any number of other considerations. But because they're no longer through acquisitions, they're no longer a part of that larger company, and so now they have to figure out other paths for solving their challenges. They no longer have access to all of that experience. Then there's also tighter profit margins, and that's driving cost saving measures, which again includes workforce reductions. And this is one of the biggest drivers for this issue is just margins are expected to not be as good this year. And I know the analyst predictions that I have heard um, have been that the at least the refining industry in general is expected to have some challenges this year. So next up, we have evolving workforce philosophies, where we have a greater focus on outsourcing expertise as a fundamental philosophy for your company. And they're more and more choosing to use outside engineering services versus your in-house or corporate engineering staffs. And the reasons for that could be anything from cost cutting or the perception that there's some efficiencies that will be gained there. But that is definitely occurring across the industry. We also have transfer of skills away from centralized engineering offices. And this is even when you have a corporate engineering staff available for you to rely on, it's less likely to be centralized in an actual single office or even on the refinery or the chemical plant or even on the property. It is very likely that if you do have a high level SME or a specialist that you can talk to, that they may be on the other side of the world using because of the technology changes and just updated philosophy that the industry seems to be moving towards. And there's nothing necessarily wrong with any of that, but it's just there's no longer as common for a quick walk down to the field to look at the equipment or having a one-on-one discussion with that expert in the particular issue you're trying to solve. It's much more likely you're going to have to set up a remote meeting of some form. And then there's also geographically based skills, and that is now much more sustained versus being a cyclical occurrence. And this is similar to the previous bullet of the moving away from centralized engineering offices, but is a little bit different in that uh, before, when you had a void in your technical area, such as as I mentioned, refractory, or even your welding metallurgist at your facility, so that would only exist until they could find a replacement. And so you had that void for a certain amount of time, and then a hire was made, and then you had another one. But now it is highly likely that that position is more likely to be filled um, elsewhere, and that could be at a different facility, or that could be at a decentralized location that could be completely remote, or again, other side of the world. Um, it's very possible it's likely to be overseas for the cost saving measures. And so you're just not, it's just not as one to one. It's not as likely to be as one to one communication as it used to be. And finally, we have human resources challenges. There's a number of these within just refining and petrochemical industries as a whole, and struggling with recruitment and retention. Um, the lack of centralized offices with a consistent process leads to inefficiency in hiring and onboarding. So you don't have the standard procedure. You have a different process for this country, a different process for that country, or this facility does it one way, another facility does it another way. And so you have some real issues with just getting people onboarded right out of the gate. And the cost cutting measures also exacerbate retention issues when workers hop for better pay elsewhere. So when you focus on cost cutting and cutting your services down to the low cost, um, by definition, it has to be a low cost. And so whenever those same engineers get experience and you're not willing to increase your pay, then they will jump ship to another company that is willing to pay more. And so that has created a significant amount of churn in the industry as well, especially overseas. And so there's a declining perception of oil and gas careers as a whole. And this is with the oil and gas industry as a whole has really taken a beating in public perception over the last decade, with um, lots of negative press, negative media, and the work in our industry is often portrayed as dirty, or the people doing the work are portrayed as careless or reckless with human life. And so it's a bad perception issue. And then it's something that I have experienced personally is a hesitancy among young professionals to enter the oil and gas industry in general. Um, and that's again due to the poor perception. But I had a student ask me one time if my job was safe because they were legitimately concerned that all of the uh, all of the oil refineries in the United States were going to be shut down within the next 10 years. And so we all know that's incredibly unlikely. Um, but they don't. And so there was just no consideration of going into the industry because they did not perceive it to be safe. So these are some of the challenges that we are faced with at a very broad, high level. And so now we're going to look at some of the key engineering tasks that are affected through the 4 case studies. And these highlight issues that have occurred because of the experience gap that we're going to look at. And so the first up is troubleshooting and diagnostics, and then we will dive into infrastructure management, look at safety critical work third, and then finally we'll follow up with some issues with problem solving and innovation. So first up, troubleshooting and diagnostics. Inexperienced staff miss complex root cause issues, and basic fixes get implemented, but the deeper issue that is apparent is unresolved. And so this is a result of just having inexperienced engineers, inexperienced personnel doing the work that are not able to identify the issues as well. So our first example, we have a seal drum failure. This is very specific to the refining industry, where you have a seal drum that maintains water level inside the drum to separate the exhaust stack from the CO boiler in a FCC unit, or fluid catalytic cracking unit. And the details behind it. But um, the background of the issue is that there were nozzles that were on this steam drum. They kept failing at the welds, and you can see in the picture there's just water pouring out of cracks that developed right adjacent to the weld toe. And so they kept failing during a hot gas bypass event where the temperature would swing up to over 1200 degrees Fahrenheit because the FCC flue gas needed to bypass during startup or shutdown or an emergency issue. And so the drum was constructed of 304 stainless steel material, and it used fire water as the water control mechanism. And that fire water is high in chlorides and other impurities to maintain the seal. So the issue that occurred is obvious. The you continued to have cracking in the toe of your welds, but welded leak boxes were placed over the cracked nozzles, and subsequently the nozzles were removed and replaced in kind, but those failed again. And so the owner wanted to improve the drum's reliability. And so that's where we ask the question: how can you close the gap on troubleshooting and diagnostics? First, for this particular instance, and then afterwards, what can you do at a high level to try and prevent issues like this at your facility? And so, first things first, it's very important to note that your fire water is high in chlorides, and chlorides lead to chloride stress corrosion cracking. And so, first up, obviously, the to correct that issue, it would be to not use fire water and removal of those impurities. The problem is that the water impurities are likely to persist from the flue gas and catalyst deposits that will build up within this drum. And so, with that in mind, the choice to go to a 304 stainless material was your fundamental mistake, and just a lack of understanding of root cause, damage mechanisms, failing to understand how your process was going to result in poor performance. And so switching the material to a carbon steel with a refractory lining, that would be more in line with the traditional industry norms. However, that equipment has poor reliability as well. And so there are a lot of uh, plants that are dry system using valves and have completely eliminated the water altogether, and that's ideal and best for this particular approach. But at a high level, so you asked the question, okay, if you had knowledge of damage mechanisms, okay, well, we would know we should not use 304 stainless material in a service that's going to be high in chlorides. But assuming that you don't have someone that you can go and ask for that answer, and you have problems that arise like this, and no one knows what to do, what do you do? And so, an idea there for helping to close the gap on troubleshooting and diagnostics is involving a diverse group of experiences and expertise that can assist with that level of troubleshooting. Your mechanical engineers can continue to try repairs, but this problem is obvious to a metallurgist. And so, getting a mixed group of or getting a mixed group of experiences involved can also help, and leveraging existing technology to gain external perspectives or potential solutions is also a method. And we're going to dive into those when we get into the strategies. So that's the first case study. Next case study will be focused on infrastructure management. And this is where we have difficulty maintaining equipment due to a lack of knowledge or expertise. And for this second example, we have a shell and tube heat exchanger where the gasket failed. And so the background for this issue is that shortly after startup from a routine plant maintenance, a leak between the shell side and tube sheet gasket resulted in a local fire. And the bolted joint had been retorqued prior to startup, and the startup had progressed normally. So there was nothing, to anyone's knowledge, there was nothing occurring that was out of the norm. The issue here is that the individual retorquing the studs prior to startup used a torque spec sheet that did not correspond to the exchanger. And could ask the question, how on earth does that happen? And that question was asked many times, unsatisfactorily answered. Um, but that is the kind of thing that we have to deal with in the industry. Is someone just doesn't they don't know any better, or there aren't adequate systems in place to ensure that you have the right equipment, or that you have the right tool, you have the right specification. Um, and so just something as simple as using the wrong sheet resulted in a local fire. And so for this particular issue, the owner wants to ensure that the joint will not leak again once it's put back in service. And so how can we close the gap on infrastructure management here? And so at a very local level for this particular exchanger, it'd be recommended to perform a thorough course of inspections to check things like your bolt up procedures, operating conditions, gasket and bolting materials, check the condition of the flange face, check the conditions of your gasket, and check your flange material from hardness from the fire to make sure that it uh, was not damaged locally if you are going to reuse it. It's also important to confirm that you have systems in place for ensuring the right information is being referenced, and that is just required to make sure that you don't have these kind of issues pop up. At a higher level, assuming that again that you don't have someone in your immediate circle that can answer the question or already knows what to do, leveraging training and workshops for best practices and things to look for can assist with maintaining equipment such as this. Also, getting management's commitment for developing a solid technical QA or QC program for such issues is very beneficial. So in the next case study that we have, we're going to be looking at how you can close the gap on safety critical work. And so some of the issues that pop up with this are limited interpretation of inspection results. And you also open yourself up to safety risks for inexperienced engineers. And so for this particular example, we had the owner wanted to re-rate a piece of a couple of large drums there that they had long since lost the documentation on. Typically refer to those as minimally documented equipment. And so these drums were built in the 1980s, but they were never put in service, and so they sat in the lay yard for the last 30 years. And at this point, the things had been passed around, so much information was lost. The only thing that was available were the nameplates on these drums that had very limited information. So the owner decided to do an inspection, and that inspection was performed on the drum, and the inspector took 4 readings on each head and took 4 readings on one cylinder. And from those results, the re-rate was performed using that data. And so the issue with this particular problem is that there were several areas of local corrosion that you can see in the picture there. It's not quite evident in that picture, but that is a very deep pit that has been growing for many years, and it's well above the exceeded corrosion allowance, and that got completely missed during the inspection. And another issue with the re-rate calculations assumed the material for the drums, even though they were built in the 1980s. We had no documentation on them. And so the owner wants to be sure that these drums are safe to use. So let's look at some of the closing the gap on some of this safety critical work. So for this particular instance with these drums, the combination of damage, inaccurate materials, and certain pressure conditions could have resulted in a catastrophic failure if more investigation had not been performed as a result of someone actually noticing and raising the question. So a much more rigorous inspection was needed for this drum, and measurements needed to be taken at more points across the vessel. Um, Tools such as automated UT or automatic UT could be used to get a more complete picture of the vessel condition as opposed to simply just using spot readings. But for this particular condition, or this case, the defect was obvious. It was just simply overlooked. The other issue is the material assumption was not good, and that there are industry documents to provide guidance on what to do in the case of unknown materials, but just blindly assuming one that may prove to be unconservative. Result of this, calculations had to be redone, and the damage should before putting these drums in service, this damage should be repaired, or at a minimum, a fitness for service should be performed. And so pulling back again at a higher level, what do you do for things like this on the job training? And again, on workshops and other training tools, as well as mentoring and having other experienced engineers to bounce ideas off can help catch safety critical issues such as these. So next up, for our final case study, we're going to look at problem solving and innovation. And the issue with these are trial and error can replace expertise-based decisions where you are, if I can use the phrase, you're throwing spaghetti against the wall and hoping it sticks. And so that leads to a lack of creative solutions, and that can lead to consistent issues, consistent rework, and failures. And so for this particular case study that we're going to look at, there was a de-superheater that was attached to bypass piping that continually experienced weld crack failures. And so the welds connecting that de-superheater to the reheat steam bypass consistently failed, where the piping was 5/8 of an inch thick, while the de-superheater body was 3.5 inches in thickness. And so the piping itself was acceptable per B31.1 based off your piping stress analysis, and it was acceptable by over a 50% margin. And the weld taper that was on the de-superheater to piping connection, it followed your standard ASME B16.25 requirements. And so it was technically code acceptable, but kept failing. And so the cracks were repaired on multiple occasions, including adding more weld to provide more forgiving taper angle. But none of these solutions worked long term. And so the owner wants to increase the reliability of the joint. And so let's discuss how we can close the gap on problem solving and innovation here. And so it's very important to note just in general, just because a design meets a code or a standard does not mean that it is a good design. It is just simply as acceptable per the minimum requirements of that code and standard. The particular issue with this configuration is the mismatch between the pipe and the de-superheater thickness, with 5/8 to 3.5 inches. It creates a significant discontinuity stress. And so adding more weld material and taper, that does help, but that is not enough. Reducing the thickness of the de-superheater also helps. But setting the de-superheater thickness to match the piping thickness from the work on this particular issue, making the de-superheater match the piping thickness increase the cycles to failure by an order of magnitude. And so other examples that you could use would be reducing the temperature gradient by the use of a thermal sleeve, or preheating or revising your operating procedures to greatly to help the cycles to failure. But at a higher level, if again, if you don't have someone in your circle that knows what to do, leveraging technology such as advanced analysis tools can assist with tracking down issues such as this, and as well as management committing to employee development to help solve issues that are very experience based. That you can design a piece of equipment and it is perfectly acceptable per the code or per a code or a standard, but it continues to fail because it is a bad design. And that those are the kind of things that you need to have. You need to have some experience developed to understand what is going on. So moving on from these case studies, so now we're going to get into part of the real meat of this webinar. And that is, so okay, we've identified these are issues that our industry is facing and the challenges that we have in front of us. We've looked at some case studies that highlight real world problems, real actual problems that have resulted, that have occurred throughout the industry. So now we're going to look at actual strategies that you or your manager or your company can implement to help close this experience gap that we've been discussing. And so first up, we're going to look at learning opportunities, such as personal opportunities that you can use for intangible ways to gain experience or professional development. Next, we'll look at technology as a support tool, looking at ways to leverage that technology to assist with learning and development. Third, we will focus on cross-generational collaboration, such as how mentoring and diverse set of experiences can contribute to your own personal growth. And then finally, we'll talk about organizational. These are ways that your organization can support you and your team with intentional and dedicated plans. So learning opportunities. Uh, First up is on-the-job training. And on-the-job training is first because it is obvious and it is irreplaceable. It's important to note that the overwhelming majority of anyone's knowledge and expertise in the industry will have been learned after we all graduate college. And and just to simply put, basically all of the strategies we're going to be covering here are some form of on-the-job training, where you learned it while you were at your job, while you were progressing throughout your career. But on-the-job training can be accomplished in several different ways. One is being involved in dedicated projects that focus on a particular technical topic. These projects can be used to get you out of your comfort zone, and they can help you learn and stretch you beyond your current knowledge base. That is the bread and butter of any strategy to help gain more experience. Additionally, you can get into a rotational program that can help you gain a wide breadth of experience that uh, many roles are requiring before you choose which area to dive into deeper, before you select an area that you would like to gain more expertise in. Uh, you can also work on, you know, getting hands-on time with tools and machinery and software for personal learning. And this can include hands-on field work to better understand what it really takes to do your job or to do a job. And also working with your peers who do the job already. And that is a great way to help help learn your job, help learn the industry, help learn the ins and the outs, is working with the people next to you that do the work already. Well, there's another focus there that I want to point out, and that is key experiences. And what I mean by key experiences are is that's determining, you know, what are the primary areas that you or your employee need to grow in, and trying to set a plan to address those areas. And so, as I mentioned earlier, engineers within your company may be spread out geographically across the world. And so it's much more difficult during the current technological landscape to have someone go and spend 2 years at a particular site to gain experience. A lot of new hires are not willing to do that anymore. So as a workaround, you can send your employees as a short stint assignment, such as a turnaround or, you know, a equipment revamp. And the intent is to go and learn everything you can about that particular unit or process in the time frame that you are there. And so that you so what but the goal there is, with the key experiences, is that you have an intentional plan on what you're trying to focus on to extend your career, and to where do I need to grow, what experiences do I need, or if you're the manager, what experiences do my employees need to be able to adequately navigate the problems that they're going to be facing, and having that intentional plan. And so, just speaking directly to anyone on the call that you would consider yourself a young engineer or an early career engineer, you know, if you don't get anything else out of this webinar, I will say, you know, perk up and listen. Just take this to heart, and that is, no one will care about your career as much as you do, and that um, you cannot wait on your manager, you cannot wait on your company to line out a plan for you. It's great if they're willing to help you with that. And we're going to talk about that in a little bit with organizational commitment and some other strategies. And I believe organizations are if you want excellence, the organization needs to support you. But I do want to just point out that the onus is on you to go and for you to learn and for you to put in the time and you to put in the work to learn. And those with a hungry and inquisitive mind, you will get there. Um, so looking at moving on to structured workshops are very valuable, and they can be anything from a lunch and learn to a multi-day offsite workshop at a conference. This webinar technically would qualify as a workshop for learning what to do to gain more experience. There are conferences all throughout the country every year that have many tutorials or workshops available. I go to the Pressure Vessels and Piping Conference every year, and they have exceptional tutorials that are very valuable every year. And so I think it's worth investing your time into attending something every year outside of your organization and to getting that outside perception, outside uh, expertise as well. Also, you can look at shadowing experienced engineers, and this is another great option for you. And they can give you pointers, they can teach you best practices for problem solving or workflows. And I personally have learned the most from simply listening to more experienced engineers ask questions and hearing how their mind works and how did they address and how did they attack this problem in front of them, and continuing to ask questions until they got to a solution. Now, sometimes those questions weren't fun and they were directed directly at me, asking me why did I do what I did the way that I did. But doing that can help you have a more inquisitive mind, and it will help you learn and grow in your career if you're open to feedback, if you're coachable. But I also want to point out, just beyond engineers, it'll be very valuable to shadow non-engineers, such as inspectors or those that are doing hands-on work, because they offer a wealth of practical experience as well as different perspectives. As engineers, we can tend to follow a similar train of thought, uh, but there may be a better way, so they can help you understand that. And last, on learning opportunities, we have external or internal training. And formal training is a solid foundation from which to build. It's uh, very, very common to send uh, someone to training to try and learn. And learning from industry experts is a tried and true way. Um, and there's more options than ever with on-demand trainings as well as virtual classrooms. Um, there's so many opportunities available for this. And I want to just offer my own personal perspective. It's not a rule. This is not a rule, but the overwhelming majority of experts that I have encountered in any particular discipline have usually had some type of formal training in their careers. That they've had someone pour into them some level of training that they've gotten that foundation to build from. And it can definitely help you identify blind spots in your own knowledge base and your own understanding. But I do want to caution you that this is listed last in this slide for a reason, and that is, again, formal training does not replace an inquisitive mind. Um, it also has reduced benefit unless the concepts you learned are reinforced soon with actual application, such as like software. Going to a training for software, learning how to push the buttons in the software won't do you any good if you go back to your office and then never open the software again. So keep that in mind. And next up, we have technology as a support tool. And so here we talk about you can leverage digital tools to help firsthand observations from remote locations. As we mentioned earlier, advances in technology have allowed us to no longer be constrained by our geographic locations like we used to be. And so some examples of this are you can leverage that technology to have your live data analytics and be able to view them at a remote location. This is very common already with operators in control rooms having access to how the plant is operating in real time. But as mechanical engineers, we can also leverage this technology by having things like a local operator wear a camera on their hard hat, and then we can and have them walk around, and then we can see what's going on in that facility, or or even perform inspections from a different country, or again, the other side of the world. And that is an actual example that I'm aware of, where an engineer here in the U.S. performed an inspection for a piece of equipment in South America using this technology. And so um, there are limitations to this approach, though, because it's hard to beat experience gained from hands-on, eyes-on time spent in the facility. But it is a tool. It is beneficial. Um, some other examples, you could have live process condition monitoring with integrity operating windows in place, so to make sure that you're operating within a certain range of parameters, so that you do not lose your integrity window, and it'll alert you if your material damage is possible if left as is. And so this can help you learn what the appropriate operating windows for your equipment is. You can also have augmented or virtual reality, which is also gaining momentum with engineers, so they're able to walk through a unit virtually, or they're able to see things virtually before actually going there physically. And there are companies that are exploring ways to incorporate that technology. There's also simulations that can provide practical experience, and that can take various forms, such as you can do general high-level scenario planning, or you can get very precise analytical tools. And scenario planning can be used to optimize operational schedules. It can be used to extend the time frame between maintenance. It can also be used for economic decision making, or to help determine the best course of action financially. Another example is risk management, such as RBI, or determining the potential severity of an environmental issue. But using these simulations can assist you with learning the thought process that goes through daily decision making, or why the system is set up the way that it is. Looking more granularly, at a more granular level, having access to design and analysis tools such as software is another beneficial approach. And that, from me personally, I know visualizations, being able to model a piece of equipment and apply loads to it and see how that piece of equipment behaves, is very beneficial in understanding the physical behavior of that equipment. But I also caution you that that still doesn't those are benefits. There are benefits to using that equipment, but that does not replace a good grasp on engineering fundamentals. So next slide. So we'll look at cross-generational collaboration. And so very beneficial approach is building mentoring relationships. And so that could be a structured mentor program that your company puts together, or it could be a personally developed mentor that you personally seek out and choose to learn under. As I mentioned earlier, interfacing with more experienced engineers can provide incredible oversight, but you have to be willing to listen and take feedback positively. Additionally, reverse mentoring can also be beneficial. Or reverse mentoring is you know, you being the mentor, and then what do you get out of you being the mentor yourselves? And that's helping others learn and grow, and that can expose you to ideas and perspectives that you may have never considered. With new generations coming up, they bring new perspectives and challenges, and they can challenge the status quo, and things don't have to be done the way they've always been done just because that's the way it's always been done. However, we don't necessarily want to change things just for the sake of changing them, but talking through the why, and from those challenges, can help solidify why it is done, why it has to be done the way that it is, and it can help you learn, and help reinforce your understanding as well. And so we have another solution is to promote team diversity, to blend experience and fresh perspectives. And I do want to be clear that what I'm saying here, and I'm not saying have a wildly arbitrarily diverse team just for the sake of having a diverse team. What I'm advocating for would be a selective, intentional diversity in experience and expertise, that we're trying to avoid groupthink, but it would help discover better and more creative solutions, help to engage a wide branch of perspectives, so that we're not just all thinking in lockstep and missing something that others would see. Um, so the inexperienced can learn from the experienced, and the experienced can grow themselves, as we mentioned earlier with the mentoring. When you have these cross these cross experienced teams, and so but other solutions can be cross disciplinary collaboration, which can be various disciplines can be put together to communicate, and this can help clear up misunderstandings, or it can help drive solutions that work for everyone and helps understand why things are the way that they are. So now we're going to talk about organizational commitment. And as I mentioned at the very beginning, this is important. Organizational commitment is very important because at some point, you as an individual, you can only do so much, and that your company has to provide support to you to learn and to grow, and your company as a whole, if you want a culture of excellence. That's not going to happen accidentally. And so one strategy is prioritizing workforce development over temporary cost savings. This is one of the biggest complaints that I have heard in the industry lately is there's a lot of concern that companies are sacrificing good people and decades of experience for that immediate cost savings because of, poor margin forecasts or others. Um, but the employee can assist with all of the strategies that we've covered in this, or the company can assist with all of the strategies that we've covered in this webinar, and the employees can forge their own path. But it's a lot easier if the company allows for time off for training or workshops, and to foster experienced teams, and to put them together, and to prioritize that over the short-term pain of the cost savings. And also should look at long-term investments for employee growth. And what that can be, that can take the form of yearly allowances for continuous learning, such as formal training, travel to conferences, or even building mentoring programs, engaging in leadership development programs, recognizing the reward and growth as it occurs within your employees. But it can also take the form of developing a structured career pathway. And that's what we mentioned earlier with identifying what are the key experiences that this employee needs to have to progress from one level to the next within their career. And so this is something, again, that the company you can do as an individual on your own, but it is much easier to have that culture of excellence if your company is willing to invest in the long-term success of its employees. And just one thing to note there, a lack of investment in your people will eventually show up on the balance sheet. That if you're trying to cut costs and save money, but not investing in your people, it's going to show up, just not in tangible ways. It'll show up through failures, equipment failures, and inefficiencies, and poor decision making. But that's hard to track. And lastly, I think it's important that your companies build and maintain a technical quality assurance program, because I mentioned at some point you've done all that you can do, and at some point you may not know the answer. It may not be something that you can solve yourself. And so your company is responsible for someone being involved that knows what to do, or that someone that can make an informed final decision. Because we don't want inexperienced engineers making calls or making decisions with no basis because they don't know any better and they have no one to bounce the ideas off of. And so that QA QC program that the company can set up, it'll help catch those bad decisions, and it'll help catch that inaccurate information. And there needs to be a final approver that can take responsibility for that. So these are the strategies that we've covered here, which are we've covered 4 strategies, which are engaging in learning opportunities, such as on-the-job training and key experiences. We've also talked about leveraging technology as a support tool. We've talked about cross-generational collaboration, and we've also talked about your organizational commitment. Hopefully there was something in there that you can all glean something from that you can take home with you. But lastly, I will say that for everyone who's attending today, there will be you can expect an email from me that will provide a gap assessment checklist that you can use that covers these strategies that we just went through, and it will help gauge where you or your company is at and what some considerations that you can take to help address those issues that we've discussed today. So with that, I will turn it back over to Jeremiah, and we can answer some questions.
All right. Thank you, Nathan. We've had a number of questions come in, and we've got just a few minutes left here. So I'm going to try to get through at least a couple here, if that's all right with you. So one of the first ones I wanted to touch on was, talking about these organizations, large organizations in particular that have, a lot of a large network of experienced engineers or inspectors, and a greater amount of resources. What do you advise smaller facilities as far as strategies? Like, what can they do when they've got limited staff and limited resources to effectively close their skills gap?
Right. So there's a couple of things that you can do there, and again, with keeping in mind that it's a small facility, so they you assume that they don't have multi-million-dollar budget for training and for development. So, but as I mentioned earlier, there are just all sorts of remote and virtual training options. I know there are lots of companies that offer virtual classrooms, that offer training that is very affordable, that you can help your engineers gain experience and learn from. Um, Also, promoting things such as this webinar are helpful. Getting people involved in lunch and learns and bringing in. I know lots of service industry companies are more than happy to treat your staff to a lunch and learn, where they bring in lunch and have a technical topic, and that costs the company nothing. Most of the time, those service vendors are happy to come in and do that, and so you can gain experience and learn without an excessive or high level cost.
Great, thanks. One of the things you brought up earlier was kind of the simulation experience and virtual reality experience. I'm particularly interested in that and hearing, if you have any specific examples, maybe you could discuss of innovative training programs or simulation technologies that you've actually seen companies successfully use to accelerate the learning curve of their new engineers and inspectors.
Yeah, and so without giving away details of the company, but yeah, I am aware of some of those instances where it's a multifaceted answer here, because it involves several different things. And number one of them being the difficulty with hiring, because they say maybe the I don't want to go work where your facility is. I want to work in some fun city. I want to work in Denver. I want to work in Salt Lake City, or I want to work in New York, or wherever. And so companies are setting up local hubs where they can go and they can have these remote engineers at that local hub and work remotely from there, while still supporting their facilities and assets that are spread out throughout the country. And to do that, they're leveraging those virtual reality and augmented reality tools to help see what's going on in the refinery. And it's still a little cutting edge. It still needs a little bit of refinement, but I have heard of examples where they are actually have the refinery and you can walk through it using the goggles.
Mhm.
And so that is an approach that
Sure.
I know at least one company that's using.
Any security concerns when using those types of tools to, enable remote observation or even control operations from remote locations?
I mean, yeah, if your local electrical grid can be hacked one way or another, I have no doubt that system could be hacked as well. Um, I guess that's the make sure you have really, really good security as best you can anyway.
Well, we'll save that for another conversation.
Yeah.
All right. Well, thank you, Nathan. We are out of time. We're going to go ahead and call it here. But thank you again to Becht, and thanks to everyone for joining us for today's webinar. I hope you enjoyed the discussion and can use some of the insights shared today to better manage the widening experience gap within your own organizations. Be on the lookout for a follow-up survey to let us know what you thought about today's webinar, as well as any topics you'd like to see covered in the future. And with that, today's webinar has concluded. Thanks for watching and have a great day.